Good morning, everyone. My name is Veronica Del Valle from BET CPET 1A Group 2. And I would like to introduce to you our topic, Zener diodes. Our objectives here is to explore the use of Zener diodes and to learn the function of Zener diodes along with its construction, operation, and more. So let's start. Zener diodes. A Zener diode, also known as a breakdown diode, and it is heavily doped semiconductor device that is designed to operate in the reverse direction. When the voltage across the terminals of a Zener diode is reversed and the potential reaches the Zener voltage, or it is also known as knee voltage, the junction breaks down and the current flows in the reverse direction. This effect is known as the Zener effect. So, ang Zener diode ay hindi lamang nagpapahintulot sa current na mag-flow mula sa anode to cathode, pero sa reverse direction sa pag-abot ng Zener voltage. Dahil sa functionality na ito, ang Zener diode ay ang pinaka-pangkaraniwang ginagamit na semiconductor diodes. Sa artikulong ito, alamin natin ang pag-andar ng Zener diodes kasama ang pagbuo at pagpapatakbo nito. So, ang Zener diode din ay isang heavily doped semiconductor device na idinisenyo para gumana sa reverse direction. Ang mga diode ng Zener ay hindi daw ginagamit sa iba't ibang mga Zener voltage or VZ at ang ilan ay ginagawang variable. History of Zener diode. Ito si Clarence Melvin Zener. So, si Clarence Melvin Zener ang kauna-unahang tao na nag-describe ng electrical properties ng Zener diode. Siya ay isang theoretical physicist. Theoretical physicist, ito yung scientist na ginagamit sa mathematics, calculations, chemistry, biology, at ang mga theories para maintindihan yung mga komplikadong gawain ng buong universe at nakikipag-ugnayan sa pagitan ng matter at energy. So, si Clarence ay nagtrabaho sa Bell Labs. As a result of his hard work, yung Zener diode ay ipinangalan sa kanya. Yung unang suggest or assume ng breakdown effect na nagtataglay ng kanyang pangalan sa isang papel ay pinublish noong 1934. So, the next reporter will be Mr. Falqueza. Thank you.
Good day everyone. Today, I will discuss the circuit symbol of the Zener diode. From the diagram, we can see that the band around the package corresponds to the line on the diode circuit symbol, and this can be an easy way of remembering which end is for which. The Zener diode circuit symbol places two tags at the end of the bar, one in the upward direction and the other in the lower direction, as shown in the figure. This helps distinguishing Zener diodes from other forms of diodes within the circuit. So, maraming paraan in which a Zener diode is packaged. Karamihan dito ay ginagamit for high levels of power dissipation at ang iba naman ay for contained with surface mount formats. Ang kadalasang common type of Zener diode is contained with a small glass encapsulation, and it has a band around the end marking the cathode side of the diode. So makikita natin sa diagram at mapapansin natin that the band around the package corresponds to the row on the symbol so that the diode ends can be easily remembered. So yung circuit symbol of the Zener diode ay nag-i-include ng two tags at the finish of the bar, where one is in the direction of upward at ang isa naman ay in the lower direction so that it helps in differentiating these diodes from other types of diodes in the circuit. And that's all. Thank you. Good day everyone. Today I will discuss the BI characteristics curve of Zener diode. When reverse bias voltage is applied to a Zener diode, it allows only a small amount of leakage current until the voltage is less than Zener voltage. The BI characteristics of a Zener diode ay nahahati sa dalawang parte. Ang una ay forward characteristics at ang pangalawa naman ay reverse characteristics. So, una nating talakayin ay ang forward characteristics of Zener diode. So, sa first quadrant in the graph, ito ay nag-represent the forward characteristics of Zener diode. So, sa graph ay malalaman natin that is almost identical to the forward characteristics of any other PN junction diode. At kapag forward bias, it works similar to the PN junction diode. It has a bias voltage between 0.3 0.7 volts. It has the forward bias characteristics which is represented in the first quadrant of the BI characteristics. At ang pangalawa nating tatalakayin ay all about reverse characteristics of Zener diode. So, sa reverse characteristics of Zener diode, when a reverse voltage is applied to a Zener voltage, initially, a small reverse saturation current I/O flows across the diode. So, this current is due to the thermally generated minority carriers. So, yung reverse voltage ay tumaas at a certain value of reverse voltage, the reverse current ay tataas din drastically and sharply. This is an indication that the breakdown occurred. We call this voltage breakdown or Zener voltage and is denoted by Bz. So, yung reverse conducting state, it conducts for a wide range of voltages irrespective of the current flow. The voltage drop across the conductor remains constant. And that's all.
So good day everyone. First of all, my name is Sergeant R. Fernandez. So I'm gonna discuss is how does a Zener diode work in reverse bias. So first of all, the Zener diode operates just like a normal diode, run in a forward bias mode and has a turn-on voltage between 0.3 and 0.7 volts. However, when connected in the reverse mode, which is usually in most of its applications, a small leakage current may flow. Or sometimes it didn't have flow or reading because the anode is a positive and the cathode is negative. So the red tester and when we're gonna put it in the anode and the black is gonna put it in the cathode, it still didn't have a reading because it's gonna reverse the flow and the testing of the diode. So which is usually is a most of application and small leakage current may flow. Sometimes it's really hard. As the reverse voltage increases to the predetermined breakdown voltage VC, a current starts flowing through the diode. The current increases to a maximum which is determined by the series resistor, after which is stabilized and remains constant over a wide range of applied voltage. So that's how the Zener diode works in reverse bias. Thank you.
Good day, I'm Christian Mark Escalo from Betsepet 1B, and today I will discuss Zener breakdown. So, kapag ang isang conventional diode, kapag naka-forward bias, yung PN junction niya, kahit wala pa tayong ina-apply na voltahe, marirecall natin na meron itong depletion region. At sa region na to, dinideplete niya yung mga charge carriers. So, yung mga Zener diode, isa siyang heavily doped PN junction diode na may maliit na depletion region. So, same lang sila sa ating diode na example kanina, pero mas marami lang yung add-up na impurities na presented sa diode na to. Kaya maliit yung depletion region niya is dahil yung electric field niya sa region na iyon ay sobrang lakas. Dahil nga sa sobrang daming impurities, madami tayong mahanap na number of charge at siya yung nagkakos ng malakas na electric field. So, the heavily doped a diode is, the more impurities you get, and the smaller depletion region ang ating kailangan. So, kapag ni-reverse bias natin yung conventional diode, mas malakas yung electric field kasi nga i-connect natin yung positive side ng ating diode and sa ating positive source. So, pero kapag ni-reverse bias naman natin yung ating Zener diode, which is heavily doped, mas malakas siya compare sa ating conventional diode dahil yung electric field niya is mas malakas. And yung conventional diode natin, kapag tinaasan naman natin yung voltahe niya, yung sa depletion region niya is wala tayong free electrons but meron tayong covalently bond electrons. So, dahil meron tayong strong electric field na nag-generate, yung mga electrons sa loob nun, kapag nag-accelerate sila, may hit nila yung mga covalently bond electrons. So, dahil sa impact na yon, maraming charge carriers yung makikreate natin. And yung impact na yon is tinatawag nating impact ionization. Pero compare sa ating Zener diode, kapag tinaasan natin yung voltahe, dahil nga narrow yung depletion region natin, yung probability ng ating impact ionization is maliit lang. So, dahil nga mataas yung electric field, siya yung nagre-remove ng electrons sa covalently bond electrons natin. And doon mag-i-increase yung mga minority charge carriers natin. So, yung phenomena na yon ay tinatawag nating Zener breakdown. So, yung next naman natin is yung specifications natin for Zener diode. So, sa Zener diode or yung breakdown voltage niya, or tinatawag nating reverse breakdown voltage, nagre-range siya from 2.4 volts hanggang 200 volts. Then, yung current IZ or yung max natin is yung maximum current sa rated ng ating Zener diode, which is 200 microampere hanggang 200 ampere. And yung current IZ or yung minimum naman natin para makapag-breakdown yung ating Zener diode is 2.4 volts. So sa power rating naman, ito naman yung maximum power ng ating Zener diode na kaya niyang ma-dissipate. So ito naman is given naman siya sa product voltage ng ating diode and dun sa current na nagpa-flow dito. So, sa temperature stability naman, so, ang Zener diode natin, kailangan, ang best fit sa kanya is 5 volts para makuha natin yung best stability. And then, yung voltage tolerance naman is nasa plus minus 5%. And ang ating Zener resistance is, ito yung resistance na kayang i-exhibit ng ating Zener diode.
Hello and good day. My name is Jericho Brian de la Cruz and I'm here to discuss about the voltage regulator. So ang voltage regulator ay isa sa application ng Zener diode. From the term itself, ang isang voltage regulator ay ginagamit to maintain a constant DC output voltage. An ideal regulator would output a constant voltage regardless of input fluctuations of variation of load current. So ang Zener diode regulator uses a Zener diode to provide a consistent voltage output. Kino-construct ang Zener diode voltage regulator with a Zener diode, and in series dapat ito sa resistor, with the Zener diode having a reverse bias configuration. So, ang Zener diode ay ideal for application as a voltage reference or regulator. Kasi meron silang feature na Zener voltage VZ when they are reverse bias. As you can see rin po in the Zener diode curve, how steady and constant the voltage across the Zener diode is after it reaches the breakdown voltage, despite large changes in current. Kaya the Zener diode is super ideal when it comes to voltage regulation. So ang papakita po natin ngayon is ang circuit for the voltage regulator. We have here the resistor in series with the Zener diode in reverse bias and in parallel with the load resistor. So the resistor in the series with the Zener diode, ang main function niya po is to limit the current flowing through the diode. And the load resistor naman po is in parallel with the diode. So ang voltage drop across the load is also equal to the Zener breakdown voltage. So ang input voltage po natin ay ang magiging unregulated voltage natin. So with the help of Zener diode, ang magiging output voltage natin ngayon is magiging regulated na. Thank you.
Hi, I'm Adrian Straviji present from Betsipet 1. To avoid damage from electrical transients, overvoltage protection is required. When the voltage exceeds a predefined level, it is a power supply function that shuts down the supply or clamps the output. To protect electronic components, most power supply have an overvoltage protection circuit. They have an overvoltage protect or OVP circuit that detects and promptly reduces the overvoltage. The Zener diode, which is the most popular method of protection, is described here. Zener diodes are frequently used as the initial line of defense against overvoltage circumstances. A Zener diode works on the same principle as a diode, blocking current flow in the opposite direction. However, the Zener diode has the disadvantage of blocking current flow in the reverse direction only over a limited voltage range indicated by the Zener diode's voltage rating. A 5.1 volt Zener diode prevents current from flowing in the opposite direction up to 5.1 volts. If the voltage across the Zener diode is greater than 5.1 volts, current can flow through it. Because of this, the Zener diode is a great overvoltage security component. A clipping circuit, sometimes known as a clipper, is a device that clips the input voltage so that it does not exceed a predetermined value. This gadget cuts off the positive or negative peak value of a cycle. As an ideal diode and a resistor are the two most fundamental components needs for a clipping circuit. A DC battery must also be supplied in order to adjust the clipping level to the required quantity. The diode functions as a closed switch when forward biased and as an open switch when reverse biased. By altering the battery's voltage and switching the clips, different levels of clipping can be generated. There are three types of clipper in clipping circuit. Positive diode clipper. During the positive half cycle of the sinusoidal input waveform, the diode is forward biased. Anode more positive than cathode. In this diode clipping circuit, the input voltage magnitude must be more than 0.7 volts for the diodes to become forward biased and 0.3 volts for a germanium diode. Next, negative diode clipper. In this case, the reverse is true. When reverse biased, the diode is forward driven during the negative half cycle of the sinusoidal waveform, limiting or clipping it to 0.7 volts while letting the positive half cycle to pass unmodified. Negative clipper circuits are so named because the diode limits the input voltage's negative half cycle. The last type of clipper is biased positive clipper and biased negative clipper. When a diode conducts The negative half cycle of the output waveform is kept to a level V bias 0.7 volt by reversing the diodes and battery bias voltage. By adjusting the bias voltage of the diodes, a variable diode clipping or diode limiting level can be achieved. Two biased clipping diodes are utilized if both the positive and negative half cycles have to be clipped. And the bias voltage does not have to be the same for both positive and negative diode clipping. As depicted, the positive bias voltage could be at one level such as 4 volts and the negative bias voltage at another level such as 6 volts. Thank you.
Hello. So in the next video, we're gonna show you how to testing the Zener diode. In forwarding bias, the anode is in the negative tester and the cathode is in the positive tester. And as you can see, we have a reading, and the reading we have is a good condition because the forward bias is have a current flow. But in reverse bias, we're gonna use the opposite direction for forward bias. So the anode is in the positive tester and the cathode is in the negative tester. And as you can see, we have no reading because we're using the reverse bias and there's no current flow in our diode to tester.